Hello everybody, welcome to my YouTube channel Easy Mathematics. In this video, we are going to discuss some useful sequence and their convergence. This sequence we should use as a formula for the further different type of problems while we are going to solve them. So the first problem is discuss the behavior of the sequence xn where xn is equals to 1 plus 1 by n to the power n. So behavior means we should discuss it is convergent or divergent. So now for doing that, it is convergent or divergent, we have to find out that the given sequence is monotonically increasing or not. And secondly, we should find out that it is bounded or not. So at first, step by step, we should proceed. So in the first step, we should verify that the given sequence is monotonically increasing or decreasing. So first of all, the given sequence is xn is equals to 1 plus 1 by n to the power of n. If we do, so using the binomial expansion for this expression, we will find out it is 1 plus n into 1 by n, that leads us 1. Then for the third term, it is n into n minus 1 by 2 factorial into 1 by n its whole square, that we can write as 1 by 2 factorial into 1 minus 1 by n, as n cancel out and n minus 1 divided by n gives us this one. Now the fourth term is 1 by 3 factorial into 1 minus 1 by n into 1 minus 2 by n. Likewise, the last term we will find out 1 by n factorial into 1 minus 1 by n into 1 minus 2 by n. In this way, 1 minus n minus 1 by n. This is our equation number 1 say. Now, in this equation number 1, if instead of n, we substitute n plus 1, then we will get n plus x or xn plus 1. That is our equation number 2. Just by replacing wherever we have the n, we replace it by n plus 1 and we will get this one. So, from this equation number 1 and 2, it is observed that definitely in the second equation, one term should be extra. In the first term, where we will find out xn, their total power is n, so their total n plus 1 number of terms are here. But as here the power is n plus 1, so that here the total number of terms becomes n plus 2. So always in the second expression, one term should be extra. Again, we know that n plus 1 is always greater than n. Now, if we take the reciprocal of this, that is 1 upon 1 plus n, so that should be less than 1 by n, that is the properties of the inequality. Now, we just take the minus, negative sign on both sides, then it becomes minus of 1 by n plus 1 greater than minus of 1 by n. After that, if we add plus 1 on both sides, then we will find out this one. So after doing this one, we can say that 1 minus 1 by n is less than 1 minus 1 by n plus 1. Likewise, 1 minus 2 by n is less than 1 minus 2 divided by n plus 1 and so on. So now if we compare the equation number 1 and 2, then we will find out each term after the first two terms are greater than over here than these terms. So always we will find out that 1 minus 1 by n is less than here 1 minus 1 by n plus 1. Here it is 1 minus 2 by n is less than the 1 minus 2 divided by 1 plus n, 2 divided by 1 n plus 1. So likewise, so finally we can say from here that xn plus 1 should be greater than xn for all n. Hence, we will find out that xn plus 1 is greater than xn. So we can say the given sequence is a monotonic increasing sequence. Next, we should verify the sequence is bounded or not. So for the bounded or not, at first it is given the equation number 1 that two terms are plus 1 plus 1. This one is our sequence. So here first term is 1, second term is 1. So from here it is clear that the xn should be greater than equals to 2 because the next terms should be added with this 2. So definitely xn is either 2 or greater than 2. Now the lower bound for xn we can say then it is 2. Here xn is equals to this expression, so that means we can write down this one as less than equals to 1 plus 1 plus 1 by 2 factorial, 1 by 3 factorial in this way. How? If we consider n tends to infinity, then it becomes 0. So that we will find out it is 1 by 2 factorial, and likewise for the rest all we will find out here 1 by 3 factorial only, next term in the 1 by 4 factorial only, and in the last term it is 1 by n factorial only. So in this way if we express, then we can say this xn should be either less than or equals to of this term. Again, this one we can say it is less than 1 plus 1 plus 1 by 2 plus 1 by 2 square plus, in this way it is last term is 1 by 2 to the power n minus 1. So now how we can write this one? So very easy. At first we know that 3 factorial means it is 3 into 2. That we can always know that it should be greater than 2 cross 2. So that means 3 factorial is greater than 2 to the power 2. Again 4 factorial we consider. Then it is 4 into 3 into 2, which should be greater than 2 cross 2 cross 2. So that we can write 4 factorial is always greater than 2 to the power of 3. So likewise, if we just replace 1 by 2 factorial by 2, 1 by 3 factorial by 2 square, 1 by 4 factorial by 2 cube in this way, so 1 by n factorial by 2 to the power n minus 1, then definitely this expression is less than of this expression. 1 plus 1, after this one the remaining entire part is in GP with the common ratio 1 by 2, so that we can express this one as here less than 1 plus 1 minus 1 by 2 to the power n, total n terms we will consider, then it is 1 minus 1 by 2 as the common ratio is 1 by 2. Now if we simplify, then we will find out from here it is that xn is less than 3 minus 1 divided by 2 to the power n minus 1. So that as n tends to infinity, that part might be 0. So that we will find out xn is less than 3 for all n. Hence we will find out that the lower bound for the xn is 2 and the upper bound is 3. So that we can say xn is bounded also. So as we will find out xn is monotonically increasing as well as it is bounded. So from here we conclude that it is bounded and increasing, hence it is convergent, and it converges to a value which lies between 2 and 3. If we take the limit of this one, then it should be converging to E, that is we will find out from the limit theory. So where E should lies in between 2 and 3, and the approximate value of E that we know, that is 2.71828182, like that. So now one more example corresponding to that, we can say that is not example, that is also formula. You can say that if xn is equals to 1 plus 1 by 1 factorial plus 1 by 2 factorial, in this way it is 1 by n factorial, then this expression is also tends to E as n tends to infinity. Actually, this one is the expression for the exponential series e to the power of x, where x is equals to 1. So that in the next video, we discuss two very important series. One is the geometric series and another one is the P series. We discuss their behavior over there. So till that, thank you. Have a nice day.